So this question was asked in GATE 2017 Electronics and Communication paper set 2, in which you have given a parallel combination of two LTI system. One is H1 of t and one is H2 of t, and these two are connected in the parallel, and the value of H1 of t and H2 of t is given. Now if you apply a input x of t as a unit step signal, then you need to find out the energy of signal y of t. So the NPTEL reference for this question is Principle of Signal and System by Professor Aditya Jagannatham, IIT Kanpur. You can find reference in the lecture, which is Energy and Power Signals. So the useful data for this question is, if you have two impulse responses, one is H1 of t and another one is H2 of t, and both these impulse responses are connected in cascaded, and input is x of t and this is your output y of t, then you can reduce this overall system configuration in a single impulse response system, that is h of t, and this is y of t, where h of t is given by h1 of t plus h2 of t. That is, if you have given a two cascaded impulse responses, the overall response will be given by the summation of the individual responses. So this is the first useful data. And the second useful data is, if you have a signal x of t and when you convolve this signal by a delta function which is at t naught, then you get output as x of t minus t naught. So these two are the useful data. Also you need to know the, if you have a system whose impulse response is h of t and input as x of t and output as y of t, then y of t can be given by x of t convolution with h of t, and the energy in any signal x of t will be given by E equal to minus infinity to infinity x square of t dt. So these are the sets of useful data for this question. So now coming to the question, you have given input x of t and this is your cascaded two impulse responses. One is h1 of t and second one is h2 of t, and these two are cascaded and your output is y of t. You have given get h1 of t is equal to 2 delta t plus 2 minus 3 delta t plus 1. This you have given h1 of t, and h2 of t is given as delta of t minus 2. So these two values are given in the question. So you can write h of t, that the overall response of this cascaded system is by adding h1 of t and h2 of t. So which will give you 2 times delta of t plus 2 minus 3 into delta of t plus 1 plus delta of t minus 2. Now your output y of t will be given by x of t convolved with h of t. Your x of t in the question you have given x of t is u of t, that is unit step signal. So when you put x of t and h of t value in y of t, then you will get u of t convolution with 2 times delta of t plus 2 minus 3 delta t plus 1 plus delta of t minus 2. So by using the relation that if you have a signal x of t and you convolve with a delta function which is at t naught, then you will get x of t minus t naught. Your y of t will be given by, when you convolve this u of t by this delta t plus 2, then you will get 2 times u of t plus 2 minus, when you convolve this u of t by this delta t plus 1, then you will get 3 times u of t plus 1, and when you convolve this u of t by this delta t minus 2, you will get plus u of t minus 2. Now you have y of t as 2 u of t plus 2 minus 3 u of t plus 1 plus u of t minus 2. So you need to find out the energy in y of t. So you can plot this y of t as you have a first unit step signal which is at t equal to minus t of amplitude of 2. So if this is minus 2, then this amplitude is 2. This amplitude as 2 till t equal to minus 1, its amplitude is plus 2 only. But at t equal to minus 1, its amplitude gets changed from 2 to minus 3. So when you change this amplitude, then it should be minus 1, because your minus 1 minus 2 is minus 3. That is, the change in the amplitude is minus 3. So its negative part is minus 1 and 2. So the initial value, so the final value minus initial value, which is minus 1 minus 2, which is equal to minus 3. So it is the change in the value is minus 3, which is at t equal to minus 1. Now this becomes minus 1 till t equal to 2. At t equal to 2, its change in the amplitude is 1. So here you can check that the final value is 0 and the initial value is minus 1. So 0 minus minus 1, which is equal to plus 1. So this is the graph for y of t. So you can find the energy in this signal y of t as minus infinity to infinity y square of t dt. So when you put minus 2 to minus 1, the value of the signal is 2. So 2 square dt plus minus 1 to 2. The signal value is minus 1. So minus 1 square dt. So when you solve this, you will get 4 into 1 plus 1 into 3, which is equal to 7 joule. So the correct answer for this question is 7.